Hi everyone, this is going to be a video walkthrough of problem 1 on CS621B Spring 2021 exam prep discussion number 8 on LLRBs and hashing. So let's get started. Given the LLRB below, perform the following insertions and draw the final state of the LLRB. In addition, for each insertion, write the fix-ups needed in the correct order. A fix-up can either be a rotate right, a rotate left, or a color flip. If no fix-ups are needed, write nothing. Okay, so there's a couple ways we can approach this problem. There's actually two ways in particular. The first way is we can perform these operations on this left-leaning red-black tree. That's it. The other way is we can look at the corresponding 2-3 tree, perform the operations there, and then see what should happen in that corresponding LLRB. Okay, so how I'm going to proceed is I actually like the former way, but I think a lot of students like the way where you look at a 2-3 tree just for intuition. So first, I'm going to walk through all of these operations on the corresponding 2-3 tree, then I'll move to the LLRB. So with that in mind, let's look at the corresponding 2-3 tree. And I'm going to expect you guys to be familiar with 2-3 tree operations. So we're going to start off with our tree having 3, 5 at the top, and then we have 1, 4, and 9. Okay, so the first thing that we're going to do is insert 7. So how that's going to look is we add a 7 with the 9 node. Okay, and the reason we do this is because whenever we insert in a 2-3 tree, we go down to the corresponding leaf node and then we overstuff it. Okay, that's always how insertions work. So let's insert 6 now. So for the insertion of 6, this is our starting state. Then what we'll do is we will put a 6 in this node right here. Okay, so once we see a node that has 3 elements, this indicates that we need to break up this overstuffed node. How we proceed is we take the 6, 7, 9. Then we're going to put 6 and 9 in 2 different nodes, and we're going to promote 7 to the layer above. Okay, then what we'll do is we'll have 6 and 9 like so. And then we'll notice that this node is overstuffed. So what we should do in this case is promote 5 to the layer above. And we can see this is the corresponding state of our 2-3 tree. Okay, so let's move on to the next one. The next one is the insertion of 2. So if we look at the insertion of 2, how that should work is this is our current state. And then all we need to do in this case is put that 2 next to the 1 node. Okay, and then I'm going to do the insertion of 8. So when you want to insert 8, this is actually not too bad either. We see that we can just put the 8 next to the 9, and there's no overstuffedness to deal with. The last one is we want to insert 8.5. So what we're going to do is we're going to add 8.5 to this bottom node. Okay, and then what we're going to notice is that this node over here is overstuffed. So what we want to do is promote 8.5 to the layer above. And now we can kind of see that the tree is in a happy place. Okay, I'm just improving my arrows for clarity. So this is the final state of our tree if it's represented as a 2-3 tree. Okay, I'm just going to keep this in mind because when we moved to the LLRB, this is a good way of checking our work, making sure our final tree will look like so. Nice. So let's keep going. I'm going to move to my presentation now. Okay, so after looking at that corresponding 2-3 tree, we're now going to dive in to see how the LLRB is actually going to get changed. Okay. Okay, so let's begin with the insertion of 7. So what we want to do when we insert 7, recall in the corresponding 2-3 tree what we did is that we put it with the 9 node, right? In other words, our tree kind of looked like so, where 7 and 9 were hanging out here. Okay? Now what we want to do is put 7 with that 9 node, but how we represent that in the LLRB is now 7 is going to be the left child of 9. And important here to note is that we use a red link to capture this relationship because in the corresponding 2-3 tree, 7 and 9 are both in that same node, right? And a red link says that two nodes connected with a red link are both part of the same node. So moving on to the next one, we're going to do the insertion of 6. So let's walk through this process. We insert 6. And then what we realize is that this node in the corresponding 2-3 tree is overstuffed. What do I mean by that? Well, when we have a bunch of nodes connected with a red link, that means they're all part of the same node. So the size of this node is 3, which means we need to promote the middle element to the layer above, right? In this process of dealing with the overstuffed node. In order to promote 7 to the layer above, we need to rotate 9 to the right so that 7 is now the top and it can get promoted with the color flip, okay? Because whenever we do a promotion, that's my way of saying taking somebody and pushing them to the layer above, we need to be in a certain configuration, and then we can do a color flip, okay? So the idea here is that we need to rotate 9 to the right so that now we're in the correct configuration to color flip and actually push 7 to that layer above, okay? So after doing a color flip, we see that now 7 has joined the root node, but now the root node is overstuffed as well. So to remedy this, let's do another color flip on 5, which signifies pushing 5 to that layer above. Nice. So moving on, the next thing that we're going to do is the insertion of 2. After inserting 2, the only problem is that 2 is a right child of 1. To deal with this, we want to rotate 1 to the left so that now 1 is going to be the left child of 2, like so. Okay. The next thing that we want to do is insert 8. And what we'll see is that after inserting 8, there's no work that needs to be done because 8's already the left child of 9. So finally, let's insert 8.5. After inserting 8.5, it's very important here to notice that if we look at this tree, right? Or if we look at this subpart of the tree, we'll see that it represents an overstuffed node. If we ever see an overstuffed node in a 2-3 tree, it tells us we need to push that middle person up to the layer above. So what we want to happen here is we want to promote 8 to the level, oh, my bad. We want to promote 8.5 to the layer above, right? Because 8.5 is the middle element here. How we want to do that is we need this trio to be in the configuration conducive to a color flip. To achieve that, we need to do some rotations, okay? In order for 8.5, right, to get all the way up here, we first need to rotate 8 to the right, and then we need to rotate 9, or rotate 8 to the left, and then rotate 9 to the right. So let's see that in action. Okay, we rotate 8 to the left, then we rotate 9 to the right. Okay, I'll walk through that once more. So the idea here is we need 8.5 to be a child of 7 so that we can color flip appropriately, okay? So how we are going to achieve that is we're going to take 8.5's parent, which is 8, and rotate the parent to the left. So now 8.5 is here. Then we're going to take 8.5's parent, which will be 9, rotate 9 to the right. So 8.5 will finally be a child of 7, and we could perform that desired color flip. So walking through that once more, we rotate 8 to the left, right? Now 8 is here. So then to push 8.5 up here, we take its parent, rotate it to the right, and then we see 8.5 is a child of 7. Finally, what we can do now is perform that color flip. So let's look at that color flip now. We color flip on 8.5, and finally, the last thing we need to do is rotate 7 to the left. So that is all for this video walkthrough. And if you guys have any other questions, you guys can leave it in the comments. But yeah, good luck with the rest of the worksheet.